more complicated motion can be represented as well. For example, we have 1, 2, 3, 4, four arrows going to the right, and we're going to say that that velocity is 1.5 meters per second. We've also got two dots that don't have any arrows. Because it doesn't have an arrow, that means that the velocity is 0 meters per second. And then finally, we've got 1, 2, 3, 4, going in the opposite direction, going backwards to the left. So that's going to give us a velocity of -1 meter per second, because if you notice, the green arrows are a little bit smaller than the red arrows. And that gets us set up for our next part, which is going to be graphing. So again, we will still have time as our x-axis for both our position time graph and our velocity time graph. And then our position will be for this axis, and then velocity for the other one. And then just, since we've labeled them, now we got to scale them and just go one at a time all the way from 0 to 10. And same thing for our other axis. And then we're going to have a position going from 1 to 6 also. And our velocity, we have our middle line, which represents 0. And we have +1, +2, and +3. And we have going down, we have -1, -2, and -3. So, starting us off, we will go ahead and start with the red section. So the red section goes from, it's going to go from 0 to 1.5, because we have a velocity of 1.5. It's going to start here and end up right here, which is after 1 second, it goes 1.5. So we'll draw that. And then the next section, we'll go to 3. The next section, we'll go to 4.5. And then the last section is going to finish up at 6. Now, for the blue, you see it stays stationary. The blue is going to stay stationary, so we want to make sure that we indicate that on our graph. And it's also still 6 meters away, because this is at 6 meters right here. So we're going to stay 1 second, 2 seconds. All right, and that represents these two dots right here, which aren't moving. The last is going to be the green arrow. Since the green arrows are going backwards, we have a negative slope. So it's going to go down 1, down 1, down 1, and down 1. So it'll look something like this. So we'll start here and go to here, and that's the first arrow, second arrow, third arrow, and then the fourth arrow. Now we make our velocity time graph. We have to look, what's the velocity? Well, look here. The velocity for the red section is 1.5. 1.5 is going to be right here between 1 and 2. So I'll make that, so that's going to be for 4 seconds. That's 1 second, 2 seconds, 3 seconds, 4 seconds. Then we have our blue. Since our blue is 0 meters per second, we're going to start here and go 1, 2, and that represents our 2 dots. And then finally, the green has a velocity of -1, and it's going to go from 6 to 10 seconds. So here's at 6 seconds at 1 meter per second, and it's going to go all the way to 10 seconds. The last section we're going to cover is how we put a written description into the multiple representations. So here we're going to start with a position time graph, and as you can see, the position time graph is, we're starting out with a line that looks like that, okay? So it's a certain distance away from the origin. So the origin is down here, and it's a certain distance away. We'll say it's about 6 meters, so 5 meters away from the origin. And it's not moving. So because it's not moving, our velocity time graph is going to look like this, because the velocity is going to be 0. And if we were to draw a motion map, we would draw dots, and as you can see, there's no arrows on those dots, and it's staying still. So that's how it would look. So there's our position time graph, our velocity time graph, and our motion map. So the next thing we have to do is we have to include a written description. So to include a written description, we're going to say, we need to say what the object is, where's the object, how fast is it going, and how long is it doing it. So starting out, where's the object? Object is 5 meters in front of start. Okay. Next step. So we said where it is. What's it doing? It's not moving. So the object is not moving. The last thing we got to do is say how long it's going to do it. And we'll just say, just make up 4 seconds. So I'm going to say that the object is not moving, and for 4 seconds. It's not moving for 4 seconds. And that's all you really have to do. And that concludes the notes.